Good evening, students. Prusty sir back with a very conceptual discussion. This time on waves, mechanical waves traveling in a particular direction. The direction known as x. So there is some confusion based on the equation of the wave. What will happen? What will be the equation of the reflected wave if the traveling wave gets reflected at a boundary? Let's say fixed boundary. So that's what I'm going to discuss. And before that, just note down my credentials, my identity. Okay, all of you must be knowing so that you can contact me, you can be in touch. Question: if a wave is traveling on a string to the positive x direction, which is expressed as y is equal to a sine omega t minus kx plus phi. What is a? Amplitude. What is omega? Angular frequency of the oscillating particles. What is k? That is wave constant. Okay. What is phi? Some phase, arbitrary phase from a rigid support. It gets reflected. So it's a rigid wall, let us say. Then the reflected rays you expressed as you all of you know, this reflected will travel towards the negative x direction. So this minus kx becomes plus kx. And there will be a 180-degree phase change. So a minus sign I have introduced here. Y is equal to minus a sine omega t plus kx plus phi. This negative sign before a indicates the phase change of pi. Okay. But now the question comes, if the wave traveling on the string to the positive x direction is expressed as a y is equal to a sine kx minus omega t plus phi. It was earlier omega t minus kx plus phi. Can the reflected wave be now expressed as this? I will make it plus. So kx plus omega t plus phi, and we will put a, because this is a rigid support, rigid reflecting surface, so I put a phase change of pi, so minus. So y is equal to minus a sine kx plus omega t plus phi. Can I write like that? Can I? That's what I'm asking. The negative sign before a indicates a phase change of pi. Okay. So a is amplitude, omega is angular frequency, phi is the initial phase of the wave, k is the wave constant, 2 pi by lambda. Okay. The string is along x-axis. अब उसका आंसर ढूंढते हैं. Let us find the answer. When the transverse wave is reflected from a rigid wall, the point of incidence on the wall, the point of incidence, point where the string is connected, the wall is a permanent node. Point of, I'll write point of string connection with the wall is a permanent node, because that is a fixed to a rigid support. So first consider the omega t minus kx form, y is equal to sine omega t minus kx plus phi. Let's put that wall as x is equal to 0. There is no loss of generality if I take wall at x is equal to 0. It doesn't matter if the wall is taken at any other value of x also. But x is equal to 0 will make it convenient, and this has no loss of generality. I could have taken x is equal to 3 also, or x is equal to 2.73294, like this, anything. Don't make any difference, because the wave whatever you name that point of fixing of that string with the wall, whatever you call it, x0, x1, but the shape finally when the when it is incident and it is reflected back, the picture will remain same only. Yes or no? That's why I told if we take x, a wall at x is equal 0, it doesn't matter at all. There is no loss of generality here. Only thing that will make us mathematically more convenient. So incident wave will have a vibration equation. What? We put x is 0. What is the vibration equation at that? A sine omega t plus phi. Since x is 0, at the wall is the vibration of the vibration equation with respect to time. Okay, at the wall. But the reflected wave vibration equation with respect to time at the wall must be such that that wall point should be a permanent node. So that must be equal to YR. YR must be, R means reflected. For reflected wave, that R implies reflection, I means incident. Is so that yi plus yr should add up to 0. So that means I just a negative of this. That's what I did. Minus sign I put. That means this minus sign also means that there is a phase change of pi. And this automatically makes this summation to be 0. So they keep the wall at a permanent node point. It is a very simple thing to observe. Therefore, the reflected wave traveling to the negative x-axis will be, this is the vibration vector. This is a vibration point of the reflected wave. It is traveling to the negative x-axis plus r plus kx. So that's why yr will be minus a sine omega t plus kx plus phi. So this will be our reflected wave from a rigid support. This is clear to you? There is no issue here. I directly wrote that in the question paper itself. In the question itself, I told that if this is your wave equation, so this is the incident wave equation, then this is the reflected wave equation. That's what I'm elaborating here. Okay? Now comes the point, the crucial point. If the incident wave traveling to the positive x direction is expressed as yi is a sine kx minus omega t plus phi, then at x is equal to 0 as wall position, the vibration equation will become a sine minus omega t plus phi. To keep the wall at a permanent node, so yr must be negative of this. Right? Just see. A negative take inside a sine omega t minus phi is the vibration equation of the reflected wave particle at wall. So that at the wall, the vibration of incident and reflected wave will cancel each other to make it a 0 permanent displacement point. Okay? Am I clear? You see, this is negative of this, so it is obviously the addition will be 0. No problem. Negative sign of A before A for phase change of pi. And the traveling reflected wave towards the negative x direction is given by plus kx you just r plus kx. So a sine omega t kx plus omega t minus phi, just plus kx r. So this is the equation of the reflected wave if it is incident wave is terms of a sine kx minus omega t plus phi. So this became how much? Reflected become a sine kx plus omega t minus phi. Yes or no? Not what we have given in this kx plus omega t plus phi with a minus sign, that we cannot use, unlike in this case. We just made it plus, then put a minus sign. We cannot just make it plus and put a minus sign. That will not work out. That will not give me the permanent node position at wow, as I have already explained. Okay. Just I'm explaining a bit more. If we express yr is minus s sine kx plus omega t plus phi, as I gave in this, if we express like this, then what will happen? At the wall position x is 0, the vibration equation become yr become a sine omega t, that is be minus a sine omega t plus phi, if we write as given in my question. So then equation 4, this vibration of the incident wave, and equation 7 which I wrote here, will they cancel? It's minus a sine omega t plus phi, and this is a sine minus omega t plus phi. Okay, if I take it outside, minus a sine omega t minus phi, this will be minus a sine omega t plus phi. They won't cancel. So wall will not be a node at all. So that's why the reflected wave cannot be described, cannot be written as minus a sine kx plus omega t plus phi with a minus sign here. We can't write that. That's what the question is. Can we write like this? No, you cannot. So what is the conclusion? Then what is the conclusion? Conclusion, I'm just writing the whole thing in a elaborate manner. If the wave equation in terms of sine omega t minus kx form, is a very simple thing. Just put a minus sign for a phase change. Then since it's traveling to the negative x direction, change minus kx to plus kx. That's it. Okay. If it is the fixed end, if it's a free end, then s sine omega t minus kx plus phi, no phase change. If it's a fixed end, there is a minus sign. If it's a free end reflection, no minus sign. Then after that, minus kx to make it plus kx. For fixed wall, minus is there, so a plus kx plus phi. If it's a free end, no minus, but omega t plus kx plus phi. This is for that omega t minus kx. Now 2. If the wave vector is given by y is s sine kx minus omega t form, better we convert it to omega t minus kx form and follow these things. So to convert it to omega t minus kx, what should I do? I take minus sign out. So y is equal to minus s sine omega t minus kx minus phi. If the reflection from a fixed end, put a phase shift of pi, so one more minus, that will make it plus, and sine omega t minus x plus phi, but since it is traveling to the negative, then it will become a sine omega t plus kx minus phi. If it is a reflection from free end, don't add any phase. Okay, that remains same minus sine omega t minus kx plus phi, but since traveling to the left, it will become plus kx minus phi. From fixed end, it is the equation for free end, omega t plus kx minus phi. Don't add any minus one more phase, because already it is minus. If I in terms of omega t minus is already minus. If I put a plus pi, again a phase change of pi, it will become plus. That will be fixed end. That's what I wrote. So equation become this for a fixed end. But a free end, no extra phase will give, say minus 1, a will be retained. in terms of omega t minus k, already it is minus. So no further minus I have to give. There is a fixed, it is a free end, no further phase change. So minus remain, but this becomes plus. So minus a sine omega t plus kx minus phi. That is the free end. Minus a sine omega t plus kx minus phi for the free end. But for fixed end, this. Okay. So as I told you, this what I wrote here also. Oh, that is a sine omega t kx plus omega t minus phi. It's a fixed end. Okay, that's what I wrote here in conclusion. This is from the fixed end. Okay. So three ends easily can do. So what you have to do, you have to convert omega is kx minus omega t. Better make the omega t minus kx minus phi. After that, if it is a fixed end, that minus again will change to plus end, and this kx minus k omega, that is the, if it is we made it minus a sine omega t minus k plus phi. Then if it is a fixed end, put a phase change of phi. You see, again I am saying, sorry, this one. If it is sine kx minus omega t plus phi, then first you take minus a sine omega t minus kx minus phi. After that is a phase change of pi. Is a fixed, if it is a fixed support, then phase change of pi, so it minus minus plus, and kx will be made positive, it is traveling to the left, that reflected wave, so minus phi as it is. So this will become a sine omega t plus kx minus phi. Why minus become a plus here? Because a phase change of pi was introduced because a fixed support. But that in free end, that minus say remains as it is, omega t minus kx become plus kx minus phi for the free end. So this is what the red one is the incident wave traveling here, and the reflected wave should be like this. So as you observe here, as it starts moving to the right, this point, the position of the wave in the above O will come down. So I need to make sure that the reflected wave also as it moves to the left, this position of the wave on the wall should go up, so that continuously they will balance to 0 point here. Zero displacement. That's what I shown. But that is just a graphical representation. But you better to better understand this discussion which I given. So always try to convert to omega t minus k. It's very simple thing. After that, fixed support, then one more phase change will become a, and plus omega kx will become plus kx. That's all. Okay, because this omega t is very significant as a particular x which are taken as 0. This omega t minus phi, and the reflected wave should be omega t minus phi with a minus. Or if it is a minus sign, that should be plus. Because kx I am going to fix. So at any time at that wall position, they should add up to 0. Okay. In fixed case. In reflection case, there is no phase change. So that minus say remains same for incident as well as reflected, and plus this minus kx becomes plus kx, and a minus phi, and this is minus phi anyway. Okay, that's it. All of you clear? Go through my discussion again and again, so that this type of questions are coming, and I am discussing this because of your feedback. You asked it, and I am sure I have clarified it. I wanted to clarify it more physically rather than mathematically. I can do that because I can take the velocity at this point. If it is moving up, then this should be moving down. If it should be moving down, this should be moving up. That will conclusively prove it. Okay, but I think whatever I have given at this point of time, physically, that will clarify your point. That will clarify your concept also. Okay, so wave is simple, provided your visualization is perfect. So try to go through my discussion again and again. I'm sure you won't face any difficulty. This black later, this for the omega t minus kx expression, and kx minus omega t is for the red. That kx minus omega t converted to omega t minus kx by taking minus sign out. After that, you can follow this black, whatever I discussed. Understood this? Anyway, I have discussed this in conclusion also, separately. Am I clear? Okay. All the best to you. I think I have clarified one of your requirement you asked for. This is diagram. Just go and look at it also. And have a nice time. Try to build up your concept. Try to build up your visualization ability. I'll be coming back with an extremely new concept and extremely useful concept, maybe electricity, in the coming classes. Thank you all. Bye for now.